ऋषि आकेश क्या ये क्या रे ये क्या लैंग्वेज है व्हाट इज दिस ऋषि आशीष का yeah so good morning everybody now let's come to this chapter. So actually I will include the geosynthetics in the principles of ground modification techniques only. So coming to this chapter, principles of ground modification techniques. Okay, so what is the meaning of this principles of the ground modification technique? So what is the main purpose? The name itself says to modify the ground, that's it. To modify the ground. Okay, so in the case of the principles of ground modification techniques, what we are going to learn is, actually I told you in yesterday's soil exploration chapter also, actually no soil is vulnerable, or no soil is a weak soil, or no soil is a destructive soil. The soil will fail by accompanying to the structure on it. For example, let me see this one. You know, quicksand and liquefaction, you know, right? So liquefaction and quicksand occurs in the case of fine sands and silts. Yes. But do you think wherever there is a fine sands and silts, there is going to be the quicksand and liquefaction? Tell me, I want answers from you. Do you think wherever there is a fine sand and silt, do you think there every time there is a liquefaction and quicksand condition occurs? No. When does the liquefaction or quicksand condition occurs? Though the soil is fine sand and silt, if and if there is an earthquake, then liquefaction comes into the existence. And if there is a upward seepage, and in such a way, that upward seepage must be equals to submerged pressure, gamma W into H is equals to gamma dash into H, then the soil will fail. Okay, so what I can infer is, no soil is a failed soil, or no soil is a vulnerable soil. The soil becomes vulnerable or fail based upon the design considerations. If you don't design properly, or if you do design poorly, then obviously soil will fail. So we cannot rely on one fact that okay, the soil is failed, that's the reason why structure got failed. No, it's not like that. Soil would be there, but you have to choose the structure, you have to design the structure based on the soil ability. That's we discussed about the soil exploration. What is mean by soil exploration? Yesterday we discussed about soil exploration, right? What is mean by soil exploration? It's a process of obtaining the soil sample and conducting the laboratory experiments to find out the properties. Okay, now the extension of the soil exploration is, okay sir, we do the soil exploration, we got to know soil is having a lesser bearing capacity. Okay, soil has this much only bearing capacity, or sir, soil has a very high permeability, or soil has very low permeability, soil has very less shear strength. We got to know the properties. Now, once I know the properties, there it is. If the soil, now I'm going to construct a structure and I know the soil property. Okay, but now you see, if the soil is good and well and good, if it has in good bearing capacity, good strength, and less compressibility, then I don't need to worry. I can directly construct the structure on the soil mass, because I got to know the soil will be able to take the load. But what if the soil has a low bearing capacity? What if the soil has a low shear strength? From the triaxial test, I got the shear strength. From the plate load test, I got the bearing capacity. Yes. So what if the strength of the soil is less, and I want to construct a heavy loaded building on the soil mass? So now think and say, what I want to go for? I want to go for a heavy structure on a loose soil. Then I can think of what are the alternative solutions. First thing first, okay, soil is loose, sir. The structure load is very high, sir. So I cannot go for the shallow foundation, sir. I can go for the deep foundation. Yes, well and good. The deep foundation is very good. The deep foundation, and it is a pile foundation. And in the case of the pile foundation, as there is a skin friction, the pile can carry more load. Yes, well and good. But you are an engineer. You have to think not only design safety aspect, you have to think economical aspect also. If you go for the pile foundation, obviously to dig the boreholes or to drive the boreholes, to prepare the piles and its installation, everything, it's a time taking process, number one, which means it involves more number of labor. The more the number of labor you involve, the more the wages you have to give. The more the wages you have to give and the more the time you have to pay, means you have to work, then obviously the cost of the construction project will increases. So if you go for the pile foundation just like that, your cost of construction increases exponentially. Okay, now your client is there. Your client says that, okay, your client asked you, please come to my site and check my soil. Let me know the structure that I wanted to construct, because he has something in his mind. Okay, so now you are a geotechnical site engineer and you went to the site. You saw the surroundings. You got the soil exploration data. And after checking, you got to know soil has low bearing capacity. But your client needs, to construct a commercial building on that. Now you know that practically to say the possibilities, you are talking to your client. So my dear client, whatever the soil you are having is low bearing capacity, but you want to go for the heavy loaded structure. So practically to say, without doing anything, it is not going to be possible. With going for the conventional way of construction, it is not going to be possible. At the same time, my client is asking me, sir, please do construct in an economical way. So his consideration is a low soil, low bearing capacity soil, and the strength of the soil is very less. Load coming from the structure is very high, and he wants to get it done within less cost because he's a contractor. If he pays too much of money from his pocket, who will pay that money? So you know that the beauty of the civil engineering is, once you construct the walls and after wall putty and painting, nobody knows what type of cement you used. Nobody knows what type of sand you used. Nobody knows how much amount of steel you have used in that construction. At the end of the day, after the construction, what we do is, once we enter into the home, okay, does the color looking good? Does it is going to be feasible to the, means aesthetically pleasant or not? That's it. Never ask, means nobody ask, have you ever heard about like some relative came into your home and array Mr. How many number of steel bars that you have used in beam? Can you please tell me? What type of column that you have used? What type of reinforcement that you have used? And what is the thickness of the brick that you used for the wall? Have you ever heard about that? No. But you can see most of the relatives that you come to home, this home seems to be small. This home seems to be huge. This home is so beautiful. The home seems to be beautiful or small or big. It's completely based on the aesthetical appearance. It does not depend upon the performance of the structure. Yes? Do you? No, it's not going to happen. So now I am an engineer and I know everything. I know soil has a bearing capacity low, and I know soil structure should be very heavily loaded structure. And I know that my client wants to get it done with less cost. So I cannot go for shallow foundation as the bearing capacity is very less. I cannot go for the deep foundation as the cost required for the project is very high. Now, what is the option I have? I have other option is, okay, the soil is loose. Let us try to improve the strength of the soil. Let us try to improve the stability of the soil. And as the soil is loose, if you construct a heavily loaded structure, obviously the structure will undergo more settlement. Yes. So, okay. soil is loose now, settlement will happen now. Okay, let us reduce the compressibility of the soil. So how you are going to increase the load, means how you are going to improve the soil properties, means improve the bearing capacity, improve the strength, and how you are going to reduce the compressibility, and that process is known as ground modification. In simple words, without going for the deep foundations, first I'm going to check by modifying the soil mass, and I'm going to improve the properties of the soil mass, and then I'll check whether the soil is suitable for the structure or not. Okay, so now I cannot construct a quality-less structure. I have to go for the ground modification. So whatever the cost I invest in ground modification would be less than the cost for the deep foundation, definitely. So now what's the main aim of the principles of ground modification techniques is to improve the characteristics of soil. What are the characteristics of soil? Engineering properties. Because what is mean by engineering properties? What is mean by engineering properties? The engineering properties is nothing but a simple, in simple words, we can say that the properties that changes under the action of engineering laws. If you apply load, the property will change. So those properties are nothing but shear strength, compressibility, and permeability. Okay. So is it a continuation of ESC extra topic? This is an ESC extra topic, my dear. This is a ESC extra topic. Okay. Now, if you observe objective, what is our objective, sir? To improve the shear strength. Such that stability and bearing capacity of soil increases. So to improve the shear strength such that stability and bearing capacity of soil increases. Okay. So now the objective is to improve the shear strength such that the stability and bearing capacity of soil increases. Next, to reduce compressibility of soil such that settlements of a structure reduces. So before construction itself, my main aim is number one, to improve the strength, number two, to reduce the compressibility. Why, sir? In chapter number 16, bearing capacity chapter or shallow foundations, I told you, we do construct the foundation by keeping some things in our mind. What are those? We should not allow the soil to fail either by means of a shear or by means of excessive settlement. Yes or no? So foundation should be designed for no shear failure and no excessive settlement. So which means I have to improve the shear strength, and in order to not to cause excessive settlement, I have to reduce the compressibility. That's it. It's not a rocket science, not need to be known. Okay. So this is going to be the to improve the characteristics, and now let's see what are the various methodologies. Number one, soil stabilization. Number 2, grouting technique. Number 3, reinforcement. Number 4, geomembrane. Geosynthetics. Number 5, dewatering techniques. Okay. So soil stabilization, grouting technique, reinforcement, geosynthetics, and dewatering techniques. These are the things that we are going to. Okay. So these are the things that we are going to discuss. And out of this, already geosynthetics I have included over here. Okay, which means the principles and uses of geosynthetics I am going to discuss in this same chapter. Okay. Now, what is the meaning of the soil stabilization, sir? In the case of the soil stabilization, stabilization means to improve the strength. Stabilization means to improve the strength. So, and to reduce the permeability, we are going to do some stabilization like a mechanical stabilization, mechanically, chemical stabilization. Mechanical stabilization is there, and there is a one more stabilization known as chemical stabilization. Okay. So now let's see what is this stabilization. Soil stabilization. In that, mechanical stabilization. Okay. So what is the meaning of mechanical stabilization? Mechanically, which means I am not going to add any chemicals. What I do is the soil, I will change the composition of the soil. I will change the composition of the soil either by mixing with another soil or by removing the extra soil. And then I am going to compact it. In simple words, in chapter number 2, we discussed about something regarding to the mixing and compaction. Remember? Mixing and compaction. Remembered in chapter number 2, I told you when 2 or more soils are going to be mixed up and then compact, such type of process is known as a mechanical stabilization. And we did a question also in that. Yes or no? Yes. So the mechanical stabilization, in the case of the mechanical stabilization, it's nothing but first grading up of soil. First we do grading of soil. Soil composition. Changes by either adding or removing the soil. By adding or removing the soil. So simply it is going to be the top layer. If the top layer of the soil is loose, then you replace with a highly graded material. If the top layer of soil is loose, it can be replaced with highly graded material. Highly graded material, which in turn improves the grading of soil. So now grading of soil. Soil composition next. So first one is the soil composition changes by either adding or removing the soil. That is. And then we are going to do the compaction. after grading the soil. It should compact. So what is the purpose of the compaction? What is the purpose of the compaction? So you know that I have given you the necessity of the compaction to improve the strength, to reduce the permeability and uneven volume changes are there. Yes or no, swelling, shrinkage, all those things. To improve to increase strength and reduce permeability, or I can say in other words, and reduces compressibility. Okay. So what are the various type of compaction we are going to do? What are the various type of compaction? In the case of the compaction, again, there are shallow compaction. There is a deep compaction. The shallow compaction, we are going to do it by means of rollers, smooth wheel roller, pneumatic tide roller, and like whatever the sheep foot roller, all those comes as rollers. And the deep compaction comes as by means of blasting technique, by means of impacting or impact loads, by means of vibro flotation. You don't need to worry what are those methods, but you just need to know what are the various methods. What are the various methods? Okay. Okay. So this is about the compaction. In the case of the mechanical stabilization, I'm telling you again, we have to know what is our main aim. What is going to be happen. That's it. So in the mechanical stabilization, I am not adding any other chemical. I'm just adding or removing the soil, and I'll improve the grading. Once improve the grading, you just simply compact it to increase the strength and reduces the permeability. Okay. So this is about the mechanical stabilization. Next, coming to the chemical stabilization. So here the main point of chemical stabilization is now I am going to add chemicals. Now I am going to add chemicals. So in the case of the chemical stabilization, what we do is we add chemicals. Sir, what is happens if I add chemicals? Here the main purpose is to reduce the permeability. To reduce the permeability. See, when you reduce the permeability, then soil will take a very long time to undergo settlement. So when you lower down the permeability, water will not be allowed to go out easily. Then settlements would be decreases. In turn, improves strength. So what are the various chemicals that you are going to use? The various chemicals that I can use are calcium chloride, CaCl2, sodium silicate, NaSiO2. Okay. So calcium chloride and sodium silicate. And then we are going to see the other chemicals like lime, CaOH twice, bitumen. So these are the various type of chemicals that we are going to use. So first, number one, calcium chloride. In the case of the calcium chloride, so this CaCl2 is a water repulsing agent. A water repulsing agent to the soil. So what happens is, I hope you remember, you remember the CaCl2 test, calcium chloride test in the chapter number 2. When we add wet soil to the calcium chloride, then immediately the calcium chloride will react with the water and it will remove the water from the soil. So CaCl2 is a water repulsing agent. CaCl2 is a water repulsing agent. It will remove the water from the soil. It add means, you know that when the CaCl2 added with the wet soil, the CaCl2 react with water and forms C2H2, acetylene gas, and CaOH twice, which is nothing but lime, as a precipitate. So CaCl2 is a water repulsing agent, and it is used to improve sandy soils in base and sub-base courses of base and sub-base course. Okay, to improve sandy soils in base and sub-base courses of pavement. Now, so CaCl2 is a water repulsing agent, and then second one is sodium silicate. So what is this sodium silicate, sir? Whenever you added this sodium silicate with water, this chemical with water along with calcium chloride, you are going to use both. So the sodium silicate plus water plus calcium chloride. When added to soil, so when you mix the sodium silicate plus water plus calcium chloride to the soil mass, what happens is this mixture will give an insoluble precipitate known as silica gel. Induces an insoluble precipitate induces in the an insoluble precipitate silica gel into voids. So thereby permeability reduces. Okay. So sodium silicate, this chemical with water along with this chemical with water along with water. So this chemical along with water along with the calcium chloride, when you add, it is going to be form a gel known as silica gel. So here the point that you need to remember is this silica gel. Here the point that you need to remember is this is nothing but the silica gel. Okay. So and next third one. Lime stabilization, which is nothing but lime. Okay. So now you tell me, where do we need to add lime? Where do we need to add lime? Any harm to environment? No, it won't harm any environment. See, whatever the ground modification we have to take in such a way that whatever the chemicals that we add, it should not be hazardous to the environment. It should be biodegradable and it should not causes the properties of the soil mass reduces with respect to time. Okay, so you are going to be take care of everything. And you see this compaction used for base courses in pavements. Next, coming to the line. So what is a line? Yeah, where do we are going to be add a line? Yes, generally we are going to treat the black cotton soil mass with line. We treat the black cotton soil mass with a line. Okay, so now used to treat black cotton soil. Sir, how it is going to be useful in treating the black cotton soil, sir? If you remember in chapter number 4, I told you, when a non-plastic soil mixed with plastic clay, resultant IP will decreases. Did I say that point? Yes. Now you see, this lime is used by addition of lime to plastic clay, by addition of the lime to the plastic clay. What happens? So when you add lime to the plastic clay, then a resultant liquid limit and a plasticity index of the mixture decreases and improves bearing capacity of the soil. Bearing capacity of the soil. See, generally for the black cotton soil, the bearing capacity is less. Generally for the black cotton soil, the bearing capacity is less. Why? Because it is a highly plastic, it is undergoes high swelling and shrinkage, so settlements would be very high. So when you add a lime to the plastic clay, a resultant liquid limit and plasticity index of a mixture decreases. When the plasticity decreases, then obviously compressibility decreases and improves the bearing capacity of the soil. Improves the bearing capacity of the soil mass. And I can write both. Lowers compressibility. Okay. That's about the line. Yes, they have used for Leaning Tower of Pisa. They have used for the Leaning Tower of Pisa also. Okay. Yes. So line used to treat the black cotton soil mass. Okay. And next one. Bitumen. Various forms of bitumen as tar and emulsion. Various forms of bitumen as tar and emulsion is used to stabilize the subgrade and base courses of gravel and sand. Okay. So in the case of the gravel and sand, we are going to use a bituminous tar and a bituminous emulsion. So we can also add some chemicals below PCC for anti-termite treatments. Can we consider this? No, that's not the soil stabilization. That's to prevent the termites. That is different. Prevent the termites, that is different. It does not improve the strength of the soil. Okay. And you see, in order to treat the cohesive soils, we are going to use a cutback bitumen. So what is the meaning of cutback bitumen, sir? Bitumen mixed with naphtha or kerosene. Okay, so cutback bitumen is used to treat cohesive soils. To treat the cohesive soils. Okay, so various forms of bitumen is there, and a cutback bitumen is there. So the third one is lime. So these are the main chemicals that we are going to use. See, the ground modification technique is a subject which implies one in one single semester. But for our examination, you observe, I mean, every 4 or 5 years or 3 to 4 years, they give one question. And they will ask a basics only. So for that, we don't need to go for like, we don't need to make ourselves to die for this chapter. So that's the reason why I'm giving you a overview, what are the various chemicals and what is its purpose. That's it. You don't need to go beyond that. And next, there comes grouting. So far and so good, whatever the discussion I have made, so far and so good, that is for the soil stabilization. So I stabilize the soil either mechanically or by adding chemicals. Now, what is meant by grouting technique? In simple words, it's just like injection. You see, when you get fever or when you get ill, doctor will give an injection, and that injection has a medicine. Yes or no? So the doctor will give the medicine by injecting into your bloodstream. Doctor gives the medicine by injecting into your bloodstream. Here, you means soil, doctor means engineer. You means soil, doctor means engineer, and the medicine means stabilizer. So in the case of the grouting technique, what we are going to do is, an engineer injects, not in by means of a small injection. So there is a heavy equipment would be there. So injecting the stabilizer. Sir, how you are going to inject the stabilizer? Array, can you take a injection in a solid form? No, no. It forms in a liquid, semi-liquid or liquid form. Yes or no? We call that one as a solvent or emulsion or solution. So what is meant by grouting? Grouting is a technique to inject the stabilizer as solvent, or you can write solution or emulsion or suspension. Solution or emulsion or suspension. Okay, so you are going to see the technique to inject the stabilizer as a solution or emulsion or suspension. The solution is going to be sodium silicate and acrylic nitrate. That's a solution. And emulsion is going to be bitumen emulsion. And the suspension, you know that soil suspension we have discussed. Now it is going to be with a cement, lime, etc. Okay. The difference between the chemical treatment and this treatment is, in the case of the chemical treatment, we directly add the lime to the soil. We directly add, while you are going to lay the base coats, we add the bitumen. And sodium silicate, while you are laying the base course, you are going to mix the sodium silicate. But in this case, I'm not going to do it after the construction. Already soil is there. If the soil is there, then how I go for that? So if the soil, for example, you see, this is the ground level, right? And there are some cracks present somewhere over here, which is at a depth of 10 meters or some 8 meters, let's say. There are some cracks. Now, how come I fill this crack? How come I improve the strength? See, when there is a crack, then you know that definitely if the load enters into that zone, the soil will fail. Yes. So now, what is our main aim of the grouting technique? What is the main aim of the grouting technique? So basically, as it is an injecting phenomena, you can do it anywhere. Yeah, do we do grout in dam? Yes, we can do it. Okay. Now, if you observe, what is our purpose in the case of the grouting is, number one, to fill the cracks or voids. When you fill the cracks or voids, then obviously the strength will increases. Yes. Second one, you know that soil cannot stand vertical. Yes or no? And if you want to do the excavation, then you have to do excavation with what slope? Safe slope. Otherwise, you have to provide the support. Yes or no? If you want to go vertical, you have to provide the support. Now, what I do is, the second one is, I'll induce a grout. I will induce a grout so that I will strengthen the soil. I will strengthen the soil. So when you strengthen the soil, the need of requirement of lateral support will be less. And third one, you know, in the case of fine sand silts, there is a possibility of liquefaction. So now by grouting by grouting this stabilizer into the fine sand and silt, I can stop the liquefaction process also. I can stop the liquefaction process also. Okay. So now, objectives. Number one, to fill cracks or fissures in soil. Number two, to strengthen the soil in a way reduce requirement of, okay, so to strengthen the soil in a way, in such a way to reduce the requirement of lateral support. Next, third one, to stabilize the soil, to stabilize the soil against, what we do is to stabilize the soil mass against liquefaction. Okay. So we are going to stabilize the soil mass against the liquefaction. Okay. Now that's about the objectives of the grouting, and let's see what are the various types of the grouting. Types of grouting. There are two types of grouting. One is permeation grouting, and second one is compaction grouting. So first, let's see what is meant by this permeation grouting. See how we are going to do the grout. First thing first, sir, how I am going to do the grout, sir? For example, if you take a ground level, you take this as a ground level, and what we are going to do is, if in order to strengthen the soil, we are going to insert a pipe known as a grout pipe. We are going to insert a pipe known as a grout pipe. Okay, so now whatever the stabilizer I'm going to use. Either I can use the stabilizer in the case of the solution. So this is nothing but a grout pipe. And once I know this grout pipe, now I'm going to send the stabilizer by means of the grout pipe, and here you can fill the grout. Here you can fill the grout. Okay. So there are a different type of groutings over here. There are different type of groutings. So this is nothing but a grout. So first one is going to be the permeation grouting. What is mean by permeation grouting? What is mean by permeation grouting? Okay, so I can take this down. So what is mean by permeation grouting, sir? The meaning of permeation grouting is when I inject the grout into the soil mass, if it does not displace, the foam technique, foam is a different, okay. When you inject the grout into the soil, if it does not displace the solid particles, it's just like a seepage, just like a seepage. I'm going to induce a chemical, means I'm going to induce a solution, and it flows as a seepage between the void spaces without displacing the soil, without displacing the soil mass. So now, if grout induces in soil, doesn't displace the solid particles, such type of grouting we call it as a permeation grouting. Such type of grouting we call it as a permeation grouting. Okay, so if the grout induces in the soil does not displace the solid particles, if the grout induced in the soil does not displace the solid particles, then we are going to call it as a permeation grouting. Now let me show that figure. Give me a minute. Okay. Okay. Now, if you take a ground level, and if there are solid particles like this, if there are solid particles like this, now if I'm going to inject the grout, If I'm going to inject the grout, this is stabilizer. And if it just passes through the voids without displacing anything, such type of grouting is known as the permeation grouting. This is nothing but permeation grouting. In simple words, you can remember it as what is meant by permeation grouting. If the grout induces in soil does not displace the solid particles, we can call it as a permeation grouting. Okay, and second one, compaction grouting. Compaction grouting. So in the case of the compaction grouting, what is meant by compaction grouting is if soil gets particles gets displaced, then such type of grouting is known as compaction grouting. And in that again, we are going to see again two types: displacement grouting and second one is soil fracture grouting. Hydraulic fracture. Soil fracture or hydraulic fracture. Okay. So in the case of the displacement grouting, what we are going to do here is just simply whatever the displacement grouting, I can show you here. This is nothing but the displacement grouting over here. You observe. This is nothing but grout bulb. In the case of the compaction grouting, first displacement grouting. Sir, when does it happens? I told you. See why the grouting is going to be having a different type of stabilizers means based upon. See, if I want to go for the permeation grouting, then it's just like a C-paste. It's just like a C-paste, then I will go for the solution. And if I want to go for the displacement grouting, here it's going to be a thick paste is used. Thick paste of grout is going to be used. In the case of displacement grouting. And if you see in the case of the soil fracture grouting or hydraulic fracture grouting, you can see this is nothing but a hydraulic fracture grouting. Whatever this is, displacement grouting. If you see the grout bulb like that, if you see the grout bulb like this, then you are going to say it as a displacement grouting. And if you see there is a flow of liquid, see in the case of the soil fracture grouting or root like lengths of hydrofracture grouting, what we are going to use is we use thin paste, more of liquid form. So when I use a thin paste, more of liquid form, it will flow into the cracks or it will pass as a seepage over here. So this is known as root-like lenses of grout. So there are different type of groutings. In simple words, if you observe, if the solid particles will not displace, we call it as permeation grouting. If the soil particles gets displaced, we call it as a compaction grouting. Okay, so that's about the grouting. That's about the grouting. And next, third one, reinforcement. Third one, reinforcement. Okay, so here the reinforcement is nothing but you know that soil is weak in tension or weak in compression. Tell me, the soil is weak in tension or weak in compression? So soil is weak in tension or not? Yes. So as a soil is weak in tension, in order to improve the strength of the soil, we use steel mesh wires. We use steel tendons or mesh wires, okay, as a reinforcement into the soil mass. To improve the strength of soil by drilling the steel tendons or mesh wires into the soil, we are going to call it as a reinforcement. In other words, we call it as a soil nailing. What we call soil nailing. I hope now you may have heard about the soil nailing. Okay, see, in order to improve the strength of the soil mass, we are going to simply drill the steel wires. It's just like a steel bar in the concrete. It's just like a steel bar in the concrete. Sir, what is the purpose? What happens? See, if I do this now, then I am going to reduce 10 to 30% of the construction cost. I don't need to add chemicals. I don't need to grout it or something like that. What we do is we just simply add that, and this will reduce us around 10 to 30% of construction cost can be reduced. $10 to 30% of construction cost can be reduced, and they are very flexible. And easy to install. Improves tensile strength. Improves the tensile strength. Okay. So the reinforcement is nothing but to improve the strength of soil by drilling the steel tendons or mesh wires into the soil mass. Now, if you observe how they do look like, and you see whatever the phase I'm showing you here, this is nothing but the soil nailing. You observe, this is there, this is nail, soil nailing. Sir, how they have prepared like this, sir? You can see set of nails will be there, right? How they are going to be prepared like this, sir? They will be preparing. Now, by seeing this figure, you can get it done. You please observe how it is going to be done. So first thing first, by using this is nothing but what? What is this is nothing but a excavation phase or a trench phase. Okay, whatever this phase, and then by using cranes, we are going to drill a borehole first. We are going to drill a borehole, and after that, the borehole, you are going to place the steel rods. You please observe. Whatever this is nothing but steel rods. First, we drill a borehole, and then we are going to induce the steel rods, and then we are going to cover it with the panels. So you see here outside projection. This is nothing but outside projection. This is known as a shotcrete facing. We call it as shotcrete facing. Whatever this paneling is there, right? That is nothing but shotcrete facing. Okay. Sir, do we do this while constructing tunnels? Yes, we do construct this, means we do use this one while constructing the tunnels. And one more example I can give you also. While you are going to construct the embankments, I hope you remember that bridge abutments. I hope you remember the bridge abutments. So these are nothing but, let's say this is a bridge abutment. On the top of it, there is a road. Okay, whatever this is nothing but a road or a pavement, and this is nothing but bridge abutments. flyover bridge abutments. And in between, what is the soil, right? In between, what is the soil? So here also what we do is we are going to induce the nails before construction. What we do is we are going to induce the nails inside. So that I can improve the strength of the soil mass. Okay. So whatever, this is nothing but soil nailing only. Yes. Okay, fine. So this is how you can see in the reality. Where do you observe the soil nails? Steel takes tensile load, my dear, not compressive load. See, when you apply the load, you observe, somebody is asking, this is compression and lateral is going to be tension, right? This is compression and lateral is going to be tension. Okay. Whatever the applied load, vertical load is going to be compression. You know that when you apply load, longitudinal compression, lateral expansion. The expansion is nothing but tension. Na? What do you mean by soil nail? This is not the whatever the steel rods is there, that is nothing but the soil nail. So it's nothing but simply this nail. Nail is a steel rod over there, which we induces into the soil mass known as a soil nail. The steel rods can be called as a soil nails. So that's all with the reinforcement also. Okay. And next, there comes the very important topic, geosynthetics. Okay. So now here, this geosynthetics. What is mean by geosynthetics? So now start listening this one. Okay. So geosynthetics, what is mean by geosynthetics? Geosynthetics are the materials made of polymers like polyester and polypropylene. So geosynthetics are the materials made of polymers like polyester and polypropylene. Polyester and polypropylene. Okay. And these geosynthetics are going to be mixed with the soil mass to improve the characteristics. So where do we use this geosynthetics? See, geosynthetics has a widely used application. In fact, to say nowadays, instead of a chemical, instead of a hydraulic, instead of a reinforcement, I can go for the geosynthetics, because geosynthetics has all the properties. It has all the functionalities. So what is mean by geosynthetics? Material made from polymers like polyester and polypropylene gets mixed with the soil to improve the characteristics. To improve the characteristics. Okay. So in that, what is our uses? Where we are going to use this one? So we are going to use this one in the case of pavements, airport runways, We use this one in the case of the railways. We use this one in the case of the embankments, earth dams, landfill, and canals, tunnels, and even beneath the foundation also. Foundation of structures. Beneath foundation of the structures. Okay. So geosynthetics. The geosynthetics are the materials made from polymers like polyester and polypropylene gets mixed with the soil to improve the characteristics. Gets mixed with the soil to improve the characteristics. So these are the places where we are going to see. And what is the functions of this geosynthetics, sir? See, we know, yes, sir, now soil will provide only in inclined position. Yes, it will provide in inclined position. Generally, we do provide in inclined position. Okay. So now, what are the major functions of the geosynthetics? Why we can use the geosynthetics? The major functions of the geosynthetics are, the major functions of the geosynthetics are, number one, as a separator. As a separator. You see, this geosynthetic I can use to separate the soil mass by mixing, or means to prevent the soil mass from mixing. The geosynthetics can be used as separators. How, sir? Sir, in the case of the road construction or pavement construction, you know that there is a subgrade, subbase, base course. Yes or no? And between every course, in order to prevent the mixing of the soils, we provide a geosynthetic. So to prevent mixing of soils, geosynthetics can use it for separation. For separation. How, sir? Now, you see, yeah. So you can say this is subgrade, and there is going to be subbase, and this is going to be a base or varying course. Okay. And what is mean by this geosynthetic here is I'm going to provide the geosynthetic in this fashion. So whatever this is, geosynthetic, and this geosynthetic will act as a separator between the soils, so not allow the soil particles to move from one layer to another layer. And one more thing, it can be used as a reinforcement also. First, one by one I'm going to say. The first function is going to be a separator. The first function is separator. Okay. And the next function is reinforcement. Reinforcement. Okay. See this whatever the just now we just discussed about the soil nailing, right? Yes. Similar to that, the geosynthetics can be used as a reinforcement to improve the tensile strength of the soil. to improve the tensile strength of the soil. We do apply this reinforcement especially in the case of the retaining walls. Especially in the case of the retaining walls. Now you see, when the wall moves away from the backfill, I told you soil will be under expansion. Remember? When the wall moves away from the backfill, the soil is under expansion. Wall moves towards the backfill, soil is under compression. When the wall moves away from backfill active state, soil will expand, which means soil is under tension. And that tension will be taken care by the reinforcement known as a geosynthetic. Geosynthetic. And third one, filtration. Third one, filtration. Sir, what is mean by filtration? You see, if I provide a filter above and below the clay layer, then will it allow the water to move easily, or will it allow the water, means if I provide the filter, then definitely the water can dissipate easily, or not? It will increase the rate of consolidation, and it will reduce the time required for the consolidation. Yes or no? So consolidation can happen fastly. Yes or no? So the other function of the geosynthetic is filtration, to allow the water to dissipate perpendicular to the plane or vertically. Improves rate of consolidation. Now, if you take retaining wall, this is a retaining wall, and this is a backfill. I can provide the geosynthetics. I can provide the geosynthetics somewhere over here. Whatever, this is nothing but the geosynthetics. Okay. So if there is any clay layer, for example, if there is any clay layer, then if there is a water table, something like this, or if there is any some rainwater is there, if there is any rainwater is going to be comes out. Now, whatever the load that you apply, means due to this the above layer, for example, this is going to be a dense sand. Due to this load, now the clay starts to undergo, means if I fill the soil mass over here, now the water can filtrate in above and below direction. So this is nothing but the cross plane. Cross plane means perpendicular to the plane. Whatever, this is a geosynthetic. And these geosynthetics can also act as a reinforcement to improve the strength of the soil. To improve the strength of the soil mass. Which is strength? Tensile strength. Keep that in your mind. Tensile strength. And next one is drainage. Sir, what is this drainage, sir? Sir, whenever the rain occurs, you know that the soil will get saturated. And in order to allow the water to drain through the weep holes, whatever, this is nothing but the weep hole. Yes or no? Yes or no? Okay. To allow the water through the weep hole, this geosynthetic membranes or geosynthetic materials will allow the water to drain. To drain the water. So this is in plane permeability or cross plane permeability? This is in plane permeability. And perpendicular, this is nothing but cross plane. Okay. So drainage is going to be in plane, along the plane or within the plane. Filtration from one soil to the other soil mass. Okay. So one is going to be separator, second one reinforcement, third one filtration, fourth one drainage, and the fifth one is going to be containment. So what is the meaning of this containment, sir? The containment is in the case of the landfills, or if you take canal rail, if you cut down a canal cut, if you do a canal cut, something like this, if you have done a canal cut, something like this, okay. If I cut the canal cut, something like this. Now, when you allow the water into this canal, there is a possibility the water can seep into the soil mass. Yes or no? There is a possibility water can seep into the soil mass. Now, I can use the geosynthetics as a barrier, to control the migration of water into the soil. I can use the geosynthetics as a barrier to control the migration of liquids into the soils. So it's nothing but a barrier to control the migration of liquids and gases. Okay, so this is a geosynthetic. In the case of the canal cut, if I provide a geosynthetic, then no water will go into the soil mass. And another way, there is a landfill. Municipal solid waste landfill. And this landfill on the top, sides, bottom, everywhere it is going to be provided with the geosynthetic. Okay. So in the case of the municipal solid waste landfill, you remember in the case of the municipal waste landfill, during rainy season, if it is a municipal solid waste, then the waste can undergo decomposition. And once it gets decomposes, it is going to be give a foul smell. Okay, and it is going to release methane gas. And when that methane gas releases into the environment or atmosphere, you know how does it smells. So it won't allow. If I provide the containment, means if I provide the geosynthetic will not allow the gases to migrate outside. So these are the various functions of the geosynthetics. And sir, does all the functions can be there in one geosynthetic? There are various type of geosynthetics, and based upon the requirement, we go for that geosynthetic. Okay. Now, types of geosynthetics. Number one, geotextiles, the most commonly used. Geonets, geogrid, geomembrane, geosynthetic clay liner, geocells, geofoam, and geocomposites. So don't worry, we are not going to go in depth. What we require is which one gives what functionality. That's it. If you observe, I can show you this one. Okay, fine. Anyways, I'll give it to later. Okay. So one by one. Geotextiles. Sir, what is mean by this geotextiles, sir? Give me a minute, please. Okay. Now let's see. Okay. Come to the geotextiles. So what is this geotextile? You observe this geotextile, the name itself textile, it's just like a shirt. Is it going to be a pervious or impervious? Pervious. It's a pervious fabric geosynthetic material. It's a pervious fabric geosynthetic material. Okay. So in the case of the geotextiles, there are two types. One is going to be woven type and other one is going to be non-woven type. These geotextiles are two types. One is going to be woven and the other one is going to be non-woven. Woven means weaving here. Okay. See how our shirt is going to be stitching. I'll give you one example. Woven is nothing but when you go to the tailor or how the cloth, whatever the cloth that we buy for a stitching, right? How that cloth has been weaved. How the cloth has been weaved. The cloth consists of threads, right? Yes or no? And those threads are uniformly and regularly spaced. They are going to be very uniform and they are going to be regularly spaced and they weaved one on other in both the direction. So if you take a shirt, you can have threads in both directions. Yes or no? In both the directions, there is a threads that is known as woven. And in the case of non-woven, you see the you see the like jackets. You means we wear a jackets, right? And you see the raincoats. In the case of the raincoats or in the case of the jackets, can you see the threading pattern? Can you see the threading pattern? No, those are made up of resins. They are not made of cloth. They are made up of the resin, polyester resin. You observe generally whatever the rain jackets we have. So those jackets are made up of leather or polyester. Yes or no? And whatever the shirts we wear, so generally they are made up of either cotton or linen. Those threads are going to be weaved in both the directions. So the woven geotextile is nothing but a cotton shirt. The non-woven geotextile is nothing but a jacket. Okay. How does they looks like? You can see. This is nothing but a non-woven geotextile. This is a non-woven geotextile. And what about woven, sir? Woven is nothing but whatever shirt. You can imagine our shirt. So in the case of the woven, uniform and regular weaving of threads in both directions. Uniform and regular weaving of threads in both the directions. Non-woven, these are prepared by hot bonding or resin bonding. So here, in the case of the woven and non-woven, these are uniform and regular weaving of threads in both directions. In the case of non-woven, prepared by a hot bonding or a resin bonding. They are prepared by means of hot bonding or resin bonding. Okay. And in the case of the woven, you can see the visible pattern of the threads. In the case of non-woven, you cannot see the visible pattern of the threads. You cannot observe the visible pattern of the threads in the case of non-woven. And these used for separation, comma, filtration, comma, drainage, and reinforcement also. Which means in the case of the geotextiles, we use mostly the woven type because the woven is going to be useful for both separation, filtration, reinforcement, except the containment, you can use this one. Why, sir? Why not for containment? Arey baba, containment, I cannot allow the water to go out, but this is a pervious. As it is a pervious member, so the water or gases will definitely penetrate into this. So geotextiles cannot be used for the containment. And if you see the non-woven, in the case of the non-woven, you cannot see the visible pattern between the threads. When you don't see the visible pattern between the threads, this one cannot be used for the filtration or a drainage, because for filtration and drainage it should be pervious. Compared to woven, non-woven is less permeable. So this is suitable. Separation only. And here it has high tensile strength. It has a high tensile strength and low strain, which means it can take a more tensile load. That's the reason why, Arey Baba, why we go for the reinforcement? We go for the reinforcement to improve the tensile strength. It has a high tensile strength and low strain, which means it won't deform that much easily. But this one has high strains and stretches easily. So as it stretches very easily, I cannot use this non-woven geotextile as a reinforcement. So the most commonly used geotextile is a woven geotextile. Now, most commonly used geosynthetics are woven geotextile. So eventually, what are its functions? Just now I told the functions for this one. So here the function is going to be, it can be used as separator, it can be used as a filtration, it can be used as a drainage, and it can be used for the reinforcement also. Okay, and generally whatever the geotextile we take, whatever the geotextile we take, this is nothing but a geotextile, right? So the geotextile is a sheets. Whatever this is nothing but a geotextile, it's going to be the sheet. Now, how does it looks like? It has patterns on both sides. It has patterns on visible patterns on the both sides. I'm just giving you as an example purpose this one, but you don't see this much amount of the spaces. Yeah. So now when you are going to allow the water, this is nothing but water, and this water gets filtered. So whatever, this is nothing but the filtration. This is filtration, and the same water can get drainage in the longitudinal, means in the lateral direction. This is nothing but a drainage. Okay, so you please observe the geotextile is going to be behaves like a both a separator and a filter. Yes or no? And in the case of the separator and filter, if you want to say, the geotextile must consist of a permeability in both the directions. The geotextile must consist of the permeability in the both the directions. Okay, so now in this case, the filtration depends upon the in-plane permeability based on in-plane permeability. Sorry. Cross-plane permeability. Known as permittivity. Known as permittivity. Okay, and the drainage is based on in-plane permeability. The drainage is based on in-plane permeability, known as transmittivity. Okay, so in the case of the geotextile, as it can be used as both filtration and separation, which means the geotextile must be having a good permittivity, good transmittivity, and it will happen if and only if there is a proper thickness. With a proper thickness only it is going to be achieved. Okay, so without the thickness you cannot get it done. Without the proper thickness you cannot get it done. Okay, so the geotextile, number one, this geotextile is going to be used for all the functions, and it is the most commonly used. Most commonly used. Now, come to the next thing. GeoNets. Actually, these GeoNets are going to be the geosynthetics used to reinforce the soil. Use it to reinforce the soil. How does it look, sir? These are going to be the GeoNets. Okay, so these are going to be the GeoNets. So it's like a grid-like structure. Generally, we use this one in the case of the, generally we use this one in the case of the to reinforce in retaining walls, to reinforce in the retaining walls. Okay, and pavements, we go for the geosynthetics or geonets. Out of all the geosynthetics, it has a high strength out of all. Possess more strength out of all geosynthetics. Okay, it has a very high strength out of all the geosynthetics, and you can see it's like a grid-like structure. Grid-like structure with large apertures. With large apertures. Okay, so geonets are out of all the entire geosynthetics. If you want to go for only the reinforcement, then you can go for the geonets. Why? Because it has very low strain and stretches maximum 2% on any load. What is the meaning of maximum 2%? The strain can be only a maximum of 2%. The strain is going to be maximum for 2%. And you see, generally these are geocells now. We means geonets we used in the case of the pavements, as I told you, to distribute the load. These distribute load uniformly beneath the pavements. Okay, so that's about the geonets. The major one is the geotextile only. That's about the geo nets. Okay, and there are some other things left over. Okay, let's have a small break of 15 minutes. We'll take a small break, not even 15 minutes, 10 minutes. Now it's 11:23. We'll take a break up to 11:35. We'll come back. We'll see the remaining things. Okay. Actually, this is not a GeoNet. This is a GeoGrid. I'm sorry. This is a GeoGrid. That's what I was thinking. So this is how the GeoGrid looks like. I'm sorry, whatever the discussion I have given. So this is a GeoGrid. Okay. So this GeoGrid is going to be, you can see large upper sizes, and moreover, these apertures are going to be the square openings. Yes or no? They are square apertures. They are square apertures. So GeoGrid is used to reinforce the soil. And next, after this GeoGrid, there is a one more thing. GeoNet. Now this is a GeoNet. Actually, GeoNet is similar to the GeoGrid. GeoNet is similar to the GeoGrid. Okay. So in the case of the GeoGrid also, you can see large spaces are there. You may ask me, can I use this GeoGrid as a separator? You see, due to this much amount of the opening, you see, the opening is going to be very large, right? Due to that much opening, the particles will enter from one layer to other layer. So it cannot use as separator. Can I use it as filter or a drainage, sir? You cannot use it as filter because while the water goes along with the water, particles will also pass. You cannot use it as a drainage also. Why? Because the thickness is very small. The thickness is less. But you see the GeoNet is a planar structure, just like GeoGrid. Just like GeoGrid. Now this is a, where is it, GeoGrid? So this is a GeoNet. In the case of the GeoNet, you can see the aperture openings, the diamond shaped aperture openings would be there. Diamond shape apertures. So that's going to be a diamond shape aperture. So in the case of GeoNet, it's nothing but a planar structure, just like a GeoGrid. It's a planar structure, just like GeoGrid. Okay. Now the grids ribs are arranged in both direction, and apertures are diamond shape. Sir, what is the function of this one GeoNet, sir? The main function of the GeoNet is, see here, unlike GeoGrid, GeoNet has more thickness and can allow in plane drainage. So the major function of the GeoNet is simply drainage. So here function is drainage. Here the function is drainage. Okay. So now in the case of the GeoGrid, here the function is reinforcement. In the case of the GeoGrid, function is reinforcement. And in the case of the GeoNet, function is drainage. Now, next come to the geomembrane. Geomembrane. Okay. You see the geomembrane, Out of all the geosynthetics, the geotextiles are more pervious and it will useful for separation filtration also. But out of all the geosynthetics, the geomembrane is a highly impervious in nature. Highly impervious in nature. It's a impervious geosynthetic material. It's an impervious geosynthetic material. Now, can you tell me by knowing this one, but this thickness is going to be very small. So what might be the uses of this geomembrane? What might be the uses of this geomembrane? Tell me. Think and say. What might be the uses of this geomembrane? Very good, very good. Containment. The biggest advantage of the geomembrane is containment. If you don't want to allow the water to seep to the soil, use geomembrane. See, for separator, mainly you go for geotextiles. See, majorly we go for the geotextiles. And if now you see, if my main intention is for the strength only, I go for the geogrid. And if my intention is I need filtration, drainage, everything, I go for the geotextile. And if my intention is to prevent the mobilization of liquid or gas, then I go for the geomembrane. So impervious geosynthetic layer acting as barrier to prevent migration of liquids and gases. That's nothing but the geomembrane. Okay. So here, as its permeability is going to be very low, the permeability is around 10 to the power of minus 11 to 10 to the power of minus 13 centimeters per second, the permeability. And uses landfill lining, canal lining, tunnel lining. For the lining purpose, we use the geomembrane. Lining is nothing but, let's see. I kept those figures, but somehow they are not opening. I don't know. Yes, you can see. This is nothing but a geomembrane. And its main function containment. The main function is containment. Okay. So this is about the geomembrane. Waterproofing. Sir, are these similar to non-woven geotextiles? No. Actually, these non-woven geotextiles are going to be pervious only. Though their weaving structure cannot be seen, but they are not impervious like a geomembrane. Next, after the geomembrane, right. Come on, yeah. Stuck. You know what? This is first time I am taking these many pages. Last time I took around 650. Now this time it is about to cross 800. It's like one textbook. If you take a Xerox of this one, I think it would be look like a textbook. Okay. Now, geosynthetic clay liners. We can simply call it as GCl. So what is this geosynthetic clay liner, sir? The geosynthetic clay liner, see, it's a properties, it's a combination of a geotextile and a geomembrane. It's like fabric like geosynthetic material. The combination of geotextile and geomembrane. Geotextile and geomembrane. See, generally these GCLs are provided above and below geomembrane in landfill lining. In landfill lining. So don't think that the GCL, whatever the GCL, it's going to be there. Don't think that the geomembrane alone itself will prevent the contamination of the liquid. So the geomembrane, on the top of that, we are going to provide GCL also. So nothing but geosynthetic clay liners. And obviously clay has a very less permeability. So it's just like it's look like in middle a geotextile, above and below clay. On the top of it, there is a geomembrane. So it's a stacked portion of geomembrane, geomembrane, clay, and geotextile. And here, this function is also simply containment. Here, this function also simply containment. This is geosynthetic clay liners. Next, geocells. So, what is this geocell, sir? You can see this. This is nothing but a geocell. And if you observe, it's like honeycomb structure. You please observe, it's like honeycomb structure. Yes or no? And moreover, you see in the sides, there are holes. And due to these holes, if I keep the geocells, due to these holes, water can pass through it or not? Yes. So these are a three-dimensional honeycomb structure. These are three-dimensional honeycomb structure. And here, main purpose is to control soil erosion and allow drainage. This is nothing but the geocell. Exam means a function. The functions are, okay, drainage only. The function is simply a drainage. Okay. So in the case of the geocell, it's a three-dimensional honeycomb structure. It's to control the soil erosion and allow drainage. The function is simply a drainage. So you have to look in the case of the functions. The functions are very, very important. Anyways, at the end, I'm going to give you the one table form. And next, geoforms. The geoform, how does it look like? Where is it figure? No. I'll show you that. Okay, so I hope you people can be seeing this one. This is how it looks like. Geoform. So whatever, this is nothing but a geofoam blocks. Here, its main advantage is separator. So what is this? The geofoam blocks? They are going to be. It's just like thermocols. Yes or no? So whatever we see, thermocol boxes would be there. No? They are like they are geofoams only. They are very lightweighted. They are very lightweighted. Lightweighted blocks formed by polymeric expansion. It's a process and filled with air. So the lightweight blocks formed by polymeric expansion and filled with air. So you can see huge blocks are there. Their main function is to separate. It will not allow the water to filtrate. It will not allow the water to drain, and it will not provide as a reinforcement also, because it doesn't have much strength. And you see this geosynthetic means a geofoam. The density of geofoam, how much lightweight do you see? The density of geofoam is just 2 to 3% of density of soil with the same strength. In simple words, I can say if you keep this geofoam on water, it can float. Why? Because at a 2 to 3% density means very less. Na? So this main purpose is just to simply separate the soil. That's it. Its main function is simply to separate the soil. Separation. And the last one is geocomposites. Geocomposites is a combination of two or more geosynthetic materials. Last one, geocomposites. It's a combination of two or more geosynthetic materials to obtain all functions. To obtain all functions. All the functions means, let me take if you take a geotextile, in geotextile, it can use as separator, it can be used as a filtration, it can be used as drainage, and it can be used as reinforcement also, but it cannot be used as containment. Okay, so what I can do is I will go with the geotextile and geomembrane. If I use both in the given system, I provide geomembrane on the outer sides, I provide geotextile in between. In between, filtration drainage will happen and it provides strength. Outside, I provide the geomembrane. It will not allow the gases or liquid to leave out. Example, geomembrane, geomembrane, geotextile. Okay. Okay. Fine. So that's about the different type of geosynthetic materials. There are no numericals. It's all about a complete theory. Not even a single numerical you are going to see. It's all about complete theory only. Give a minute. Okay. Now, so whatever the functions are, the total functions, geosynthetics, the functions are separation, reinforcement, drainage, filter, containment. See, if you don't want to go to all the slides, you just remember this one slide. It will provide you everything. So geo textiles, geo grid, geo net, geo membrane, geo geosynthetic clay liners, GCL, geocells, geofoam, and geocomposites. So these are the various type of the geosynthetic materials. Now let's see what are the separations. I mean, what are the purposes? Okay. So in the case of geotextiles, it can be used as a separator. Yes. It can be used as reinforcement. Yes. Drainage. Yes. Filter. Yes. But containment. No. Yes or no? So the geotextiles can be used all except containment. So what about well foundations and sheet piles? See, actually, there are in the given whatever the from the past 2 to 3 years, whatever the syllabus they are mentioning, they did not mention anything regarding to well foundations or sheet piles. Okay, you don't need to worry about that. And I have one solution for that also. Okay, so once the ESC syllabus has been notified, or 2022 syllabus. So if you see in that syllabus also, there is nothing mentioned like sheet piles or well foundations. So you don't need to bother about those things. You don't need to bother about those things. Okay. And if you see the geogrid, if you see geogrid, so the geogrid is going to be used as a separator. No, it cannot be used as separator. The geogrid is going to be useful for the reinforcement only. So remaining are just we can into. And GeoNet is completely only for the drainage. GeoNet is only for the drainage. Yes. Geomembrane is only for the containment. And GCL is also going to be only for the containment. Geocells. What is the purpose of geocells? Again, geocells is going to be useful for the drainage. And geofoam, it can be useful for geofoam is going to be useful for the separator, whereas geocomposite, separation, reinforcement, drainage, filter, and containment, everything you can use it. So this is how it works. Okay. This one table gives everything. Hope you understood. So that's all about the total ground modification techniques, principle of ground modification techniques, and geosynthetics. And you see the dewatering techniques are simply the dewatering techniques are like deep well point system, electro-osmosis, vacuum method, sumps and ditches. Okay. So what is the meaning of dewatering technique? The dewatering technique is simply to remove the water from the structure, means to remove the water from the soil mass. So I'll just give you in a figure. No. Also not there. Yeah, okay. But anyways, okay, fine. So the purpose of this what is this dewatering techniques is, see, you know that whenever there is a water table, the rise of water table reduces the bearing capacity, shear strength, and effective stress. In simple words, the dewatering technique means you are going to lower down the surrounding water table by means of some methods: deep well point system, electro-osmosis, vacuum method, and sometimes sumps and ditches. You don't need to go too much into the methodologies and all those things. Here, if they ask questions, they are probably going to ask questions from this geosynthetics. They are going to be probably ask you the questions from the geosynthetics. Okay. Let's see those questions. I hope you can see the question here itself. Yeah. If you observe, the correct arrangement of the geotextiles to serve reinforcement function. The correct arrangement of the geotextiles to serve reinforcement function. So this is not the way. How we are going to provide the geotextiles? So geotextiles are going to be provided in this manner. Yes or no? So this is the correct way. The geotextiles are not going to be provided in vertical and horizontal. They are not going to provide. That sheet is going to be spread on the horizontally. So no need to study sheet piles well foundation. That's what I'm saying. Foundation of the expansive soil. See, what I'm saying is, yeah, earlier there was like a foundation on expansive soils were there, and there was well foundations. There was sheet pile walls also there. If you go through the previous ESC material, you can get all these things. But in the last 3-4 years, geosynthetics and the principles of ground modification techniques has been introduced. Okay, and from then onwards, they stopped giving the well foundations, or you see the sheet pile walls, or you see the foundations and expansive soils. There are no questions appeared in recent years. So forget about that. If you see the last 2 year syllabus, I am progressing towards the last 2 year syllabus. Yes, I did teach about the retaining means sheet pile walls, and I did teach about the foundations and expansive soils also. But I don't want to waste your time. So for your examination, what is required? That's only you read now. According to the syllabus, we are going to the pattern. If they would have given foundations on expansive soils, for state service examinations, for some of the state service examinations, that chapter is there. But for you, you don't require. Okay, if you ask me, I'll show you some things you observe here. First, let me complete this. Wait a minute. No. Now let's see this question. So here the answer is the option C. Now let's come to the next question. The typical permeability of the geomembrane, it's nothing but 10 to the power of minus 11 to 10 to the power of minus 13 centimeters per second. Pick up the most impermeable geosynthetic from the following. Pick up the most impermeable geosynthetic from the following. Woven geotextile, non-woven geotextile. So most impermeable is nothing but geomembrane. Most impermeable is nothing but geomembrane. Okay. Yeah. Now you see the fourth question. Question number 4. So if you see the question number 4, read the following about geosynthetics: drainage, containment, reinforcement, filtration, and separation. Okay. So in this, which one is going to be the functions geosynthetic includes? They are going to be include everything, right? So it can be used as drainage, containment, reinforcement, filtration, and separation. To perform the drainage function, the geotextile, you know that for the drainage is in-plane permeability, cross-plane permeability. It's nothing but in-plane permeability. So drainage is nothing but in-plane permeability. It must be having sufficient amount of thickness. So good in-plane permeability. Cross-plane permeability is for whom? Filtration, sufficient thickness, and transmittivity or permittivity. In-plane transmittivity, cross-plane permittivity. So good transmittivity. What is the answer? 1, 3, 4. The correct answer is going to be 1, 3, 4. And regarding to the principles of ground modification technique, I'm telling you and I am ordering you, don't go beyond these points. Do not go beyond of this, whatever the provision I have provided you here, whatever the things I mentioned, do not go beyond these points. Okay, because if you want to explore the principles of ground modification techniques is going to be too high. The principles of ground modification techniques is going to be too vast, I can say. So there are many methods, but we don't require all those things. So keep that one thing in your mind. There is a possibility of around 3 to 4% or 3 to 5% only to get a question from this chapter, which means on an average, so let's say like every 5 years or 6 years, one question, or they may or may not question. So do not spend too much of time in these chapters. First, you do spend more time on the first 18 chapters. Okay, on first 18 chapters only you do spend more time. So do not spend more time on the remaining chapters, whatever the chapters. What I'll do is I will add the well foundations, and I will give you the foundation and expansion soils. My previous notes I'll share with that. But I'm telling you, as per the present syllabus, it is not there. If you wish to read, you can read that also. As per the present syllabus, it is not there. So do not worry about those chapters. And as per my observation, and with respect to the paper pattern given in the previous years, if you study the 19 chapters in the geotechnical engineering, that's fine. The 19 means 18 up to the pile foundation, and 19 chapter principles of ground modification, which I included the geosynthetics in this. So that's all for the ESE extra syllabus. Okay, so if you have any doubts, you can ask me now. I'm raising an option, raise a hand option, so you can ask any doubts now. In afternoon session, we'll be completing the in afternoon session we'll be completing. In first session we'll complete the remaining 19 soil exploration chapter, and then we'll discuss about the GATE and ESE 2020 and 2021, two papers I have ready with me. So we'll discuss about those two papers. Mr. Ash, you can speak out now.
Sir.
Yes.
Sir, I have a doubt in that negative skin friction, sir.
Tell me.
Sir, in that we have taken the minimum value between that QGNI and QGNB. Why, sir?
What? QGNI?
And QGNB.
Minimum value. You are discussing about, is it going to be a failure point or is it going to be a resistance?
Failure point, sir.
Yeah. So when you design, you take your failure, you have to take the worst possible scenario or best possible scenario.
For failure, sir, worst possible scenario.
Yeah, worst possible means what is the maximum failure that can happen? Yes or no?
Yes, sir.
And that based upon that only we can design. And when you are taking a strength, you are going to take your high strength or low strength?
Low strength, sir.
Yes. That's
okay,
it.
Okay, sir. Yes, sir. Thank you, sir.
Okay, fine. Tomorrow there is no class. Tushar Gowde, please give important chapter list in ascending order for geotech. That I'll give you in afternoon session. Afternoon session, more of the time I'm giving you for the revision for the previous chapters only. Okay, so that's the reason why I asked you people to come at 2:30 to 8:30. We'll be having from 2:30 to 4:30. We complete the syllabus. From 2:30 to 4:30, we'll complete the syllabus. And then onwards from 5 to next 8:30, we'll see the GATE 2020, GATE 2021 question paper, ESE 2020 and ESE 2021 question paper, so that you will get to know where, in which chapters the questions are asking more. Okay, that we'll see later. Okay, so what about offline class? And I'll tell you the offline class. So the offline classes are going to be anyway 6th. From 6th of this month, offline classes are there. So those people who wish to come to the offline, you can come and you can join. If you are exclusively online class, I mean, if you have taken itself as online, you can contact the management and you can ask if you want to shift the to the offline classes or not. But for the people, for the flexible batches and for the people who has taken only offline coaching, so it's up to you. If you want to come to the offline, you can come. Or if you want to continue with the online, yes, in online also classes would be going. So it's up to you. Okay. The ESE additional subjects already it is mentioned, right? For the EST additional subjects, whatever the additional subjects are there, So for you, especially, we are going to provide you deep learn access. The deep learn is a recorded videos. I hope everybody knows that. So it has a very good content in that. They will give you access to the deep learn. So you can go through that. And the classes are in Kottapet, not in Abids. Offline classes and online classes, same faculty are different, same faculty. So what do you prefer among online and offline? Which is best? I mean, it's not about me, it's about you. Syllabus will complete, both in both cases, syllabus will complete. That's not a problem. Okay, see, it all depends upon one's individual perspective. ESE students, ESE, give me a minute, I'll let you know. Okay, what about the remaining small doubts? I'll ask the management, I'll let you know. So the ESE classes where, and for the subject also, I'll let you know tomorrow, I mean today, what subject it is going to be start. Okay. Fine. So that's all for now, and we'll meet at 2:30. The grand final, the grand last episode of geotechnical engineering that we'll see in afternoon session. Okay, take care. So 2 hours, have a break, and we'll meet again. Fine, bye.